Hello everyone, I am Tushar Ravikant Dubey along with my friends Pradeep Chaudhary and Pooja Chopra. So today we are going to present our project management presentation on the topic of extensive controls for San Francisco's Metro Turnback project. Next slide please. Introduction. So by the late 1980s, transportation in San Francisco's financial district, an area built of over loose fill, which had once been part of the bay, had become a serious problem. To provide relief, the city launched the Muni Metro Turnback project to increase capacity and provide for further expansion. The 11-year planned project consisted of building a pair of twin tunnels 18 feet in diameter and a sixth of mile long under the busiest street in San Francisco, connected to a concrete box 23 feet high by 55 feet wide by a fifth of a mile long under the second busiest street, opening onto a 386-foot retaining wall and emerging surface track. Next slide, please. This is basically the map that shows the entire project and how it's functioning. In this map, the entire structure consisting of the project has been showed and the various elements of the project has been discussed over here in a detailed manner. So this map is an overview of the project from its starting phase to its ending phase. Next slide, please. The project consisted of design and construction of twin steel lined tunnels 840 feet long diameter extending from the Embarcadero station under Market Street and Justin Harmon Plaza to connect with a concrete box structure 1,120 feet long by 55 feet wide by 23 feet high, constructed under the Embarcadero roadway. Before the Muni Metro turnback was completed, traffic and public transportation along San Francisco's historic waterfront had become severely congested. Construction under Market Street and the Embarcadero was challenging, with possible disruption to traffic, business, annual events, and tourism. Specific construction risks and challenges included. From next slide onwards, my friend Pradeep Chaudhary will be continuing. Over to you, Pradeep.
So, hello everyone, my name is Pradeep and I'm going to explain the PMP metrics, that is project management plan metrics of this Metro Turnback project. So basically for this project and for this completing this Metro Turnback project, several departments are involved and these projects are belong to the under presidents and higher authorities. So basically, these higher authorities communicate and plan, discuss with the metro for this metro turnback project with the other departments like the general manager, project manager, team leaders, and there is also scope management option for the communication with scope management and scope of this project of this metro turnback project. Basically, a general manager will look for the R&D departments, R&D department and control and work and also control the whole project activities under the higher authorities and pass the order to the project managers. Project manager has the control of all the activities involving the project clients, time schedule, cost, project communication, and communicate with general managers. And the project manager also control the risk of this metro turnback project. And because project manager play an important role in this PMP matrix, so it's have the ability or to have responsibility to handle all the responsibility related to this project. And because successful making this project successful, project managers have the basic and most important role by concluding time and schedule, project cost, communication, and risk. And yeah, there is personal option, personal opinion as well. And the team leader will also play the very important and responsible role for this project because team leader control the all the work activities or which are handling on the ground level, and team leader manage the whole activities which are happening on ground level, like managing the workers, their schedules, their time, their arrangement, and the project location, selecting the project location. This all the project from starting to end it will be communicated with the higher president, with the president level and higher authorities, with the help of general managers, project manager, team leaders, and there is their sub roles like risk by controlling their R&D departments and they're controlling their project time and schedules. Now the questions arises which are for first question which are arise like what are the construction risk and the challenges involved in this project. Basically, this project will this project are reconstructed project, so so it will be have like it will all also they take more cost and manpower to reconstruct. And biggest challenge is that is like that the arrangement of all the activities on a single place for this project, because this project is reconstructed on the side of San Francisco River, and the tunnel will pass directly over the BRT tunnels, and it in place only 4.5 feet away from the river, and it lose full fill and mud with bay water tables, and its wooden piling that are supported was the in bygone years would be encountered with the required major forces to cut further to gathering the BRT tunnels. And the excavation would also pass the near many high valued buildings and some of the historic designations. So these are the major challenges we can say for this project. And another now the next part, or we can say the next questions will take my colleagues Pooja Chopra. Pooja, continue.
Thank you, Pradeep. The next question is the control system involved in this project. So the control system was management plan and control system. It involves the project code of account included the work breakdown structure and cost code of accounts, which gave the appropriate schedule and cost code for reporting and monitoring. The control budget included the quantities, cost, job allocation for the project code of account plus any approved scope changes. The trend program tracked scope changes and identified any potential cost impact due to new changes, ideas, direction, or requirements. The project manager used this tool to make decisions to keep costs under control. The scope change log listed any changes identified from trend program which then had either to be approved or deleted. A monthly contract cash flow schedule reflected expenditure, so contractor invoice could be compared with the expenditure schedule. The CMSS was the oral plan for the total construction scope. The schedule was issued monthly for comparison of actual with planned progress. Analysis were made of critical and near critical paths, areas of high risk, opportunities for schedule improvement, and so on. The construction schedule was derived from the CMSS above and was for coordination with the general contractor. The 3 week rolling construction schedule showed completed activities the previous week and those planned for the current and coming weeks. It was used to monitor progress and against a baseline construction schedule. Quality control and quality assurance responsibilities were segregated and divided between contractor and construction management. A system of contractor non-conformance report and corrective action report was established. By the end of the project, only 30 of these reports had been issued over the 11-year duration. Next question about how do you think quality control and quality assurance were divided and their responsibilities? Okay. Prior to bidding the MMT project, it was decided that to achieve the project overall quality control goal, the construction contract will clearly separate quality control and quality assurance responsibility for the contractor and the construction management. The quality assurance team program to ensure that the design met the city objective was established. Calculations, drawing, specification, and study report went through a rigorous review process that included internal checking and coordination of project independent review by a special consultant board, and review by the city's organization. The project management maintained a master control log of design drawings, specification, general contractor submittals, and other documents on computer to ensure that only the latest issue was issued in design and construction. The construction issue of drawing was reviewed, signed, and stamped by a registered professional engineer and completion of each design and construction phase. All project documents were sequentially archived so they can be retrieved easily and quickly. The inspectors worked with the contractor in the field discussing need for correction as the proceeded. The construction management team conducted between 4 and 8 quality surveillance review per month, approximately about 180 in all. Despite the 3-year time span, the design changes, piling, sunken ships, and resulting archaeological complications, the team effort resulted in insurance of less than 30 contractor non-conformance non-conformance report and corrective action report. So next slide. These are the references where we are taken the material, and thank you.